Section 5.3 is dividing polynomials. Number 1 is a binomial divided by a monomial, which is one term. So when you divide by a monomial, all we need to do is divide each term by that monomial. And remember, we're just going to divide the coefficients. So 4 divided by 2 is a 2. And then when you divide like bases, subtract the exponent. So remember, there's a known 1. So 2 minus 1 is 1. And the one that's left over is in the top of the fraction. Okay? And the next one, we're going to say 8 divided by 2 is a 4. And then these a's cancel each other out. So we just left with 2a plus 4. Number 2 is also division by a monomial. So it's 1, 2, 3. This is a trinomial divided by a monomial, but all division by monomials we do the same way. We're going to divide each term by the monomial. So if I want to look at this as my first move, I say 4 divided by 2 is a 2. The x squares cancel. And then I say this term and this term are like terms. So when you divide like bases, subtract. So 2 minus a known 1 is a known 1. Okay, I'm done with that term. Now I want to do the middle term divided by my monomial. So I'm going to say 6 divided by 2 is a 3. When I subtract the x's, it's 2 minus a known 1. There's one x left over, but it's going to be in the bottom because that's where the larger exponent's at. And then when I subtract the y values, 2 minus a known 1, there's 1 left in the top. And then we have our last term, don't forget the signs. Negative 4 divided by 2 is a negative 2. Okay, there's an x squared left in the bottom. And then for my y's, 2 minus a known 1 is 1, but 1 y is left in the top. So whenever I'm done dividing, this is what I'm looking at. Alright, what's different with number 3 and the rest of the problem? It says, first of all, our direction tells us to use synthetic division. Now, for most of you, synthetic division is a new procedure, so you're just going to have to kind of see it happen a few times before you start picking up on the procedures of it. So it's okay if it looks a little confusing at first, you'll pick up on it. There's a couple of things we need to make sure that we do when we set up synthetic division. First of all, it's division by a binomial. And we want to make sure that our dividend is in descending order according to the exponents of the variable. So x squared, then an x to the first, and then a constant. So since these are in order, they're ready to go. And there's no missing place values. So what we're going to do to start synthetic division is we're going to do opposite of this. And real quick, opposite of that, because if I set x plus 2 equal to 0 and I solved it, you can see x equals negative 2. Okay, so that's why we use our opposite. So if I have negative 2, and then we also have x squared, the coefficient is a 1. The next coefficient for this is a 3. The next this is our constant, which is a 2. Okay, once we have everything in order, now here's our procedure, and like I said, it may take you a few times. You're always going to drop the first. Drop the first. Now we're going to multiply negative 2 times 1 is negative 2. And now we add straight down. So I'm going to say 3 minus 2 is a 1. And it's like start the process all over again. Now I'm going to multiply negative 2 times this one and get negative 2, and then add down. So I said 2 minus 2 is 0. Now our last column is always going to be our box, and this is our remainder. Okay, this represents our remainder. Now, when you divide, if you have a trinomial divided by a binomial, and essentially you divide an x out of it, if you take this one and you divide one x out of it, the degree of this term is going to drop 1. So the highest order of this dividend is a squared, my solution is always going to be 1 less. So since this is x to the second, my answer starts with x to the first and keeps going. Well, then there's a no x. So this is simply x plus 1 with no remainder. Alright, let's look at number 4 so you can see a little bit of a procedure going on. We said check this in order. It's an x squared, it's an x, it's a constant, so that's good. Make sure this is a known 1. It is. So now we're going to set it up, and we're going to start with the negative 1 here, because we said we do opposite of this. So negative 1, drop the coefficients, drop this coefficient, now I'm going to drop negative 6, and then I'm going to drop the negative 8. Okay, all the problems set up. Now we're going to drop the first, and then we multiply. Negative 1 times 2 is negative 2. Add down. Negative 6 minus 2 is negative 8. Start over. Negative 1 times a negative 8 is a positive 8. Add down. Okay. Go back and look at your original problem. It's an x squared term, so my answer is going to be 1 degree less. So it's going to be an x term. So I get 2x minus 8. Okay. Synthetic division is the main method we're going to be using in intermediate and also college algebra, which is your next course. But there's also another method called long division that solves these problems and you get the same results. But like I said, our focus is going to be synthetic. Okay, let's go through our checks. X squared and x, constant, good. We have a problem here. This is usually a known 1, so I need to get it to be a 1. So the way to get it to be a 1 is divide by 2, but I can't just divide that by 2. I'd have to divide everything in the problem by 2 and then rewrite it. So first of all, I have to rewrite this one. X squared plus 3 halves x minus 1 by x plus 2. Okay, now I'm ready to go ahead and work this problem. So I have a negative 2 because I use opposite of this one. Drop my coefficient of x squared, drop my coefficient of x, drop my constant. Bring down the first. Now I multiply. Negative 2 times 1 is negative 2. And now I need to add down. I'm going to go off to the side and add 3 halves to negative 2 over 1. I need them to have a common denominator of a 2, so multiply. And this becomes negative 4 over 2. So I'm going to say 3 minus 4 is going to be negative 1 over 2. Multiply. A negative times a negative is a positive, and 2 times 1/2 is 1. So add down and I get a remainder of 0. My original degree is a second degree, so my solution drops 1 degree less, and it's x minus 1/2 with no remainder.